Hi, today I will be presenting my SciTech cross-curricular. It is a cross-curricular between chemistry and manufacturing, technological design, and such other courses. Today I will be discussing an innovation that I have come up with. I go to Chinguzi Secondary School, which has a SciTech North regional program. So this is the cross-curricular project I have created. It is based on a Cobas 6000 analyzer. My project in this case was to create something with people with anemia, pregnant ladies, that they can figure out their blood levels, blood concentration levels at that certain given time, and then have to wait a week or 2 weeks to get their results back. This is very useful for this type of people, as they can get their blood tested and see right away what their levels are and how much they may require, if they need to take pills, yes or no. So basically the steps to test for hemoglobin. So the steps are, as I was saying, is there are bottles inside, as you can see. Those bottles have tons of different solutions. One will be filled with citric acid, 200 millimoles per liter, Theora 115 millimoles per liter, and a little bit of detergent. This is just a way to break apart our iron in our body, as the process that will be happening is iron is going to be broken apart into trans-Phe complex, which is going to be broken into apotransferrin Fe3 positive, and by using the ascorbate, we can break it down to a Fe2 positive, and it can be further be broken to Fe2 plus ferrozyne, and this can be used in a color complex that I have created that will measure the concentration of hemoglobin and display it upon the screen. Second order of business. After a couple of minutes, finally the machine will add 20 ULs of sodium ascarbonate, 150 millimoles per liter, ferrozyne 6 millimoles per liter. This reaction will take about 10 minutes to occur. After this reaction has done, next a blood sample is taken by, as you can see, these pipettes that will deliver using the gears and rat gears to the other side, as there is a cuvette there for testing the hemoglobin levels, as this will test our hemoglobin levels that next will be displayed on this screen. So you may be wondering, how in the world do I get my blood? So there are two ways. There's a needle that will be later attached to this that can insert into your veins, and can be connected to a test tube, which will be in a bath. Or you can prick yourself, since it only becomes 8.5 UL of the patient's blood. That is approximately 0.00085 milliliters of blood. So I believe that this is possible to be prick yourself and take that blood. As this was designed in AutoCAD and it has been perfected, as the gears move up and down, so will the pipettes. As the pipettes move, they can transport everything around. There were many parts to this. There were gears, cases, display screen, test tubes, and I will be going through that in a while. This is a model of my rack gear. As it shows, these are all the teeth, and this will carry it around. This is a test tube, and this is how big it will be and how much it will carry and how much will it produce. These are my pipettes that will suck the blood or any type of solution that needs to be transported. And also the first test tube, as you can see, will be in a 37 degrees bath, and there are coils inside that will warm it up. On the back side, there is a battery pack right here, and this will heat anything as to be heated, so the coils will heat up, which will cause the water to heat, as this is a very crucial step to converting iron to Fe3+. Now I will show an animation of how everything was put together. So as you can see, all the parts come together perfectly and they join and work. What I need your help with is to figure out, how can I further improve this machine? Is it really practical? And how can I make this more beneficial? Thank you for listening to me. This is Herbal Chima from Chikuzi Secondary School, SciTech.